So nowadays, nearly all communities meet the sulfur dioxide standard set by EPA, which is a very good thing. And this picture shows you how those PowerPoint plants keep burning the fossil fuel and release those sulfur dioxide into the atmosphere. The next category of pollutants I want to discuss is the nitrogen dioxide. And they are formed when fossil fuels are burned. You can see burning fossil fuel has a lot of bad consequences. And the nitrogen and the oxygen molecules in the air combine with one another when subject to the high temperature of combustion. So automobile driving produce a lot of nitrogen dioxide. And about 75 of the nitrogen monoxide produced by automobile engine is converted back to nitrogen and oxygen by the catalytic converter. So nowadays, due to the engineering changes on the automobile, we decrease a lot of the nitrogen dioxide by just to change the components of gasoline and changing the mechanism of the engine combustion that greatly have this pollutant under control. I want to point out that although all communities meet the EPA standards for nitrogen oxide, they remain a problem because they contribute to the development of photochemical smog. I put a picture here to attract your attention and let you to think about driving cars again. It not only release those greenhouse gases, it also release a bunch of harmful chemicals. And the changes to automobile and the fuel they use have significantly decreased the amount of nitrogen dioxide produced. And I will give you a case study on this, and we rethink about the automobile driving again on our environment, on human health. Okay, so I think this is the last one, lead. Lead mainly was used in gasoline to prevent engine corrosion, and nowadays, because it accumulates in the body and causes mental retard, because of this bad health consequence, almost all countries have phased out lead as an additive to gasoline. Another source of contamination is a paint. In the old home, still there's a lot of lead in the painting. So those are the mainly sources of lead contamination. And the good news is if you read the last paragraph of the slide, you will see recent years, the lead contamination was reduced a lot. And I also want you to wonder why. What did we do to have that contamination under control? The last few, I'm not going to test in my exams, but I definitely need to know what is volatile organic compounds. They are mainly hydrocarbons. They are mainly organic compounds which are nasty and have unique features. And the source of those gases, those compounds, include internal combustion of engine solvents. So it also greatly from burning process. I want to emphasize is the VOC contribute a lot in formation of smog. That's the point I want you to keep in your mind. I definitely don't require you to write the chemical formula of those compounds, but I want you to know they are the culprits of the chemical smog. And we use those chemicals in household, but mainly they come from industrial processes and automobile driving. The last one is hazardous air pollutants. They mainly come from industrial processes. And the chemical and the petroleum industry are the primary sources of hazardous air pollutants. So now we move into photochemical smog. This is my test point. So we talk about the primary air pollutants, right? We talk about secondary air pollutants. The primary air pollutants are those directly released into the air. And the secondary pollutants are those that are created in the air from existing pollutants, which are the products of the chemical reaction of the primary air pollutants with something else. So the photochemical smog, that involves the production of the secondary air pollutants. It's a further extension of the primary air pollutants. I want to emphasize how it happens. I want you to imagine photochemical smog. All the reactions, okay, leading to the smog, it's like a cooking pot. It needs temperature. It needs sunshine. I want you to have those 2 points firmly rooted in your mind. How chemical smog formed? One, it has a bunch of ingredients in the pot, right? You have to have something to cook. And those ingredients are the primary pollutants. And then you need to have high temperature. You need to have the sunshine. That's why it's called photochemical smog. It has something to do with sunshine. And the two most destructive components in this smog is ozone and the PAN, peroxyacetyl nitrites. And you probably feel very overwhelmed. Oh my goodness. But if you look at the words here, ozone, this ozone is not the ozone in the stratosphere. It's a ground level ozone, which is a serious pollutant. And if you examine this word PAN, you see nitrates. So we talk about those nitrates, right, in the atmosphere. Those contributing to the smog and the acid rain. So I want you to have something in your mind. Ozone and the nitrates, those are most active components of the smog. Ozone, O3, is a molecule of 3 oxygen atoms bonded to one another. And the ground level ozone is a serious pollutant. It's very oxidative, it's very reactive. It reacts with our body, with our lungs, with our respiratory system. And that is very irritating, that is very harmful. Again, this ozone is not the ozone in stratosphere. However, in the upper atmosphere, ozone serves to screen out UV. So don't think this ozone is that ozone. This ozone is a ground level ozone. That's a serious pollutant. How the smog forms? It has several ingredients to start to be cooked with. Nitrogen monoxide, nitrogen dioxide, VOC must be present. So these are the ingredients. It's like you're making a mashed potato. You have to have potato in the place, right? You have to boil them and mash them. That's your cooking material. And then you add other things like butter, gravy later, right? But to cook a smog, to cook a smog, you need to have nitrates and volatile organic compounds present. And where those things come from to the air is from the burning of the fuel and other industrial processes. So it's released by human activities. And definitely sunlight and warm temperature are needed for this process. I will go over this with you. So the nitrogen oxide react with oxygen that forms nitrogen dioxide. With the sunlight, okay, the nitrogen dioxide forms NO plus this atom oxygen. The atom oxygen is very, very reactive. It reacts with the oxygen molecules and forms ozone. The ozone or the atom oxygen, which is very reactive, they will further react with organic molecule and release free radical. And the free